Hello class, so this is the start of the videos going over the final study guide. First off, I want to go over how to use it effectively. So don't just watch the videos. That's not going to be as helpful as if you try the problem first on your own, then listen and watch the video for that particular part, then try it again on your own and repeat until you can solve correctly. I cannot stress enough, you should be listening to these videos. This is your first time doing it this way, you are late to the game. So make sure you are listening. I will say a lot more than I will write. You can always watch the videos again and make me say it again if you didn't catch it the first time. Alright, without further ado, on to the work we go. Alright, so in this problem, we have Jerry dragging a sled, always draw your pictures, of 30 kilograms along the ground at an angle of 25 degrees. If Jerry pulls with a force of 130 newtons, that means this vector is 130 newtons, the sled moves at a constant speed. Remember, if we have constant speed, that means your forces are equal. So the sum of all your forces in this direction is equal to the sum of all your forces in this direction. This is important. The question is, what's the coefficient of friction? So you should draw a free body diagram. So you have a box represented by this point going up at a 25-degree angle with this force. It's also on Earth, so that means it has some Fg. If it's on the ground and it's not falling through the ground, that means it must also have some normal force. And if it is being dragged on the ground, it also has some friction in the opposite direction of movement. So you have to add up your directions in two directions. So you need two equations. So those two equations would be all of your forces in the x direction and all of your forces in the y direction. So if we have forces in the x direction, we need to break this up into components. I know, exciting. To do that, we need to be using our SOHCAHTOA, your sine, cosine, and tangent. In this case, the y, because it is opposite, would be your SOHCAHTOA. So, sine opposite over hypotenuse. So we know that. In our y direction, sine of 25 is equal to our opposite, what we want. So this would be sum of our Fy over our hypotenuse, which we know to be 130 newtons. Move this around, so you would get 130 newtons times sine of 25 will just equal your Fe. Alright, also in the y direction, we have Fn. And note, this is positive because it's going up, so this is important now. Alright, we also have some Fn. We don't know, but we do know it is going up, and it is therefore positive. And we have some negative Fg, or we could just plug in mg, mass times gravity. And remember, you do know the number for this. This is your mass, 30 kilograms, and I'm going to use 10 here, negative 10 for your downward gravity, so you get negative 300. The key thing is that you know that all of this needs to add up to 0, so we can write ourselves an equation. And I'm going to solve this so it gets less messy. So if you solve this, you would get 54.9. So we know that 54.9 plus this is equal to or actually minus 300 is equal to 0. So if we do this, we can very easily find out what our Fn is. If you solve for Fn, you would get 245 newtons. So we know what our normal force is. Alright, this is important because we want to find the coefficient of friction, but if you recall, your coefficient of friction is the force of friction is equal to mu times Fn. So we need Fn. And we finally got it. Alright, what we also need to do, so in the x direction there's only two things. That's the force of your friction and the force of your pull. But remember, we're going to do the same thing. It's 130 newtons, but this time it's cosine of our theta, 25. If you plug this into the calculator, you'll get 107.8. And again, we know that this also must add up to 0, so we can write a brand new equation where we could say, you could do it one of two ways. You could solve for force of friction first and then solve for mu. I'm kind of in the idea of just skipping that. So we're going to put our force of friction as negative because it is going to the left. So we have our positive force in the x direction. Then we have our negative force is force of friction. I'm just going to substitute mu Fn here. And we already know what Fn is, so we can plug in 245 here. And we know all this must equal 0. So you can quickly solve this. So we know 117.8 must be equal to mu times 245. Divide by 245 on both sides. And therefore mu must be 0.48. So we know that the coefficient of friction in this case is 0.48. Hopefully this was helpful. On to the next one. Alright, so some notes about 3. 3 can be solved a ton of different ways using your kinematics equations. I'm going to do one way, because to show all of them would take some time. If you did it a different way, but you still got the right answer, you are probably doing okay. So, this is the idea of we have a car that's going to hit something. Here's my terribly drawn car. And it's going to hit something, and you want to figure out, do you have enough time to stop? So, again, there's a lot of ways, but one thing you could do, you could figure out how much time do you need to stop. So, and that would be with your v equals v naught plus at. So we could figure out how much time do we really need. So this is, acceleration is -4, your original velocity is 25, your end velocity should be 0, because that means you're stopped. So if you solve for t here, you will get t equals 6.25 seconds. So you need 6.25 seconds. Now you need to figure out, is 6.25 seconds going to get you to brake within 200 meters? This is where your position problem will be helpful. So we could say that our x is 0, and that hopefully this answer should be less than 200. If it's more than 200, we hit. So plug in your numbers again, where this is 25. We now know t to be we need at least this much. Half, -4, 6.25 squared, plug all this in, you would get 78 meters. So you're going to stop in well enough time. You're going to actually stop at half the distance. So your car is very good at braking. Keynote, the reason this is negative is, remember, you are decelerating, you are slowing down. That means your velocity is positive, and then we have a negative acceleration. So, just keynote. Alright, next problem. So, yes, you could stop. Alright, looking at number 4, you again, like number 2, have an issue because it's in 2 dimensions. So you have some eraser. Your eraser has this initial velocity from when you were running with it. But remember, you don't run down, you run sideways. So it's going in the x direction. So make sure you know that it is in the x. Alright, and then if you drop your eraser, it doesn't have an acceleration in the x, but it does have an acceleration in the y direction because gravity. So it'd be negative 9.8 or negative 10. So I want to know how far horizontally from the drop point will the eraser land. The only way to figure that out is we need to first figure out how long will it take to hit. The only way, and that is a y direction problem. So we want to figure out the position, when the position in the y direction equals 0. Well, let's first write the equation. So it'd be x initial in the y direction plus our v initial in the y direction times time. Time does not have a direction. Well, that you need to worry about. And t squared. So first off, to solve this, we can know that final position should be 0, the ground. Initial position, we start at 87 meters. We don't have an initial velocity. You didn't throw it at the ground, so this goes to 0. We do have a negative acceleration towards the ground, and then we have our time squared. So you want to quickly solve for t. Your time will not be negative, so you can discard that option. 0.417 seconds. So that's how much time it will take to hit. So we know the time you're working with. Now we need to go and plug it into your position for your horizontal, because you want to know how far horizontally it's going to land. So now we have our position of x, which we do not know. We know our initial position is where you dropped it from, and while that has a height, it doesn't necessarily have a horizontal distance, so this can just be 0, which is nice. It does have some initial velocity, so you do want to keep this term, and it doesn't have an acceleration because, again, there's no current force acting on it, which makes this problem a lot easier to solve. So you just have your position is equal to your initial velocity times the amount of time it went for. So it would go about 1.46 meters in the horizontal or x direction. Alright, so those are all I'm going to do for this page. If that's all you needed help with, move on. Otherwise, I will do a little bit more on this video. Alright, so this one I'm mostly going to talk about. This one is if you drop 2 rocks, one with a mass of 1 kilogram and one with a mass of 10 kilograms, which has a larger acceleration? Trick question, on Earth, it's the same. So if they're near the surface of Earth, what's the exact acceleration of each? 9.81 meters per second squared. It's on Earth. They have the same acceleration. Alright. 13. Explain the difference between constructive and destructive interference. Give an example of each. So your example of each, where this is constructive, that they are going to get larger. If you have destructive, they cancel each other out, so you're going to get a flat line. The difference, constructive adds up, destructive breaks down. Alright, wiffle ball, this is just an F equals MA problem. Move on. Define polarization. Give an example of polarization. Define Doppler effect. Give an example of Doppler effect. I could spend a lot of time explaining this to you in a video, or you could Google it and find a new video that will pretty much, actually probably do better because I'll spend more time on it. So I would advise, honestly, Googling that and looking up an informational video. I will probably attach some informational videos into the little doobly-doo at the bottom. 16, why does a spoon look bent in a glass of water? It's refraction. Again, Google this. And again, I'll probably link some videos to this. Because refraction is really cool, and you should see some interesting refraction work to help you remember. Fire truck moves away from you and then passes you, what-da-da. Hopefully, if you did this question, it should answer this question. This page, most of it, you could have probably Googled. Alright, this one, again, you should really know the first law and second law of thermodynamics. This would be a place where flashcards could be helpful if you are into flashcards. Otherwise, Google it, watch some videos. Really not more I should say about that. Entropy, remember entropy had the idea of disorder. I'm going to link my favorite video of this, because I think it does a really good job explaining it. Electromagnetic waves, waves in the electromagnetic spectrum. Those are all the waves you cannot see, including light. So what speed do all they travel? Speed of light. Difference between light and X-rays, that is, you could either say it's their frequency or your wavelength, because both would be correct. List all the types of EN waves. Again, Google all of them. There's a large spectrum of them. You should have an idea of the spectrum. Why can you not hear any sounds in space? Again, Google will answer, but the key idea is there's nothing to vibrate, therefore how could you hear anything? Where does sound move most quickly? Remember, it's where particles are closest together. Vacuum, they're not close at all. Steel, they're very close. Water, they're pretty close. Air, they're not very close either. Vacuum, as in not close at all, as in there's 0 particles. So, quickly, it should go in the order of steel, water, air, or vacuum is the most slowest. Or the slowest, the most slow. Alright, so again, 24 is another wave and sound question. This has to do which particles are denser, hot air, cold air. Again, Googleable. Hot air is less dense, cold air is more dense. Therefore, sound will travel quicker in cold air. Wave speed equation. This basically needs, all you really need to know is that this is a wavelength. And then if the wave moves at this fast, V equals frequency times lambda. Same thing. This is the speed of light, C. You don't really need to know that, but it's kind of cool. What are seismic waves? You live in California. You should really know what seismic waves are. They could strongly affect you. Seismic waves are the waves in the earth caused by, most commonly in our area, earthquakes. Are seismic waves transverse, longitudinal, or both? There are both, because there are 2 types of seismic waves, S and P. Again, I will try to find you a good link that explains it better, hopefully with some video and pictures. This will all be down in the doobly-doo below the video. Alright, is this wave longitudinal or transverse? Explain how you know. If you Googled a picture, you could have found it. Key idea, transverse does this. Longitudinal only does this. So this is absolutely longitudinal. What does every type of wave carry? The key idea, a wave is just energy moving. It is a way that energy moves. This is important. Alright, so looking at the first one, you have 3-point charges, or the one in the middle. It's a little hard to see, but it is a negative, positive, and a positive. And we want to know what's going to happen to this one. What will it do? Hopefully you can look and think, oh wait, the one next to it's a negative, there's one farther away, so it is being repelled, but it's mostly being attracted, so it is going to go to the right. Then an electron flies through a region with a charged plate where it's positive up here and negative up here. What is an electron? Hopefully you know it's negative. Which direction will it want to go? Up or down? Think about it. 33, 9-volt resistor. So this is the idea, or 9 volts across a resistor. the resistor really doesn't matter in the sense that, remember, if we have 9 volts, by the time we get home, we need to have 0 volts. So how many volts had to be lost here? The only answer would be 9. Kirchhoff's loop rules. Alright, next one is wavelength. This basically is, can you find one full wave? Do you know what that looks like? 35. 2 masses. I'll pull distance apart. This is based on the universal force of gravitation, where G is just a number that you should probably look up. Alright, and then work heat in an engine. So how much work has been done by the engine, how much work, or what is the efficiency. So this is where you just need to label the energy input and the energy output, where the Q input, the Q in is 1000, the Q out is 450, Q in is equal to work plus Q out. So you could figure out the work that way. And then there's 2 efficiency equations. Either one would work, which could either be work over the input, or also equal to 1 minus the work out over the work in. Alright, I'm going to cut this video off here. I will finish at some point going over the other ones before Monday. Might be this weekend, might be tomorrow. We shall see. Hopefully this is helpful. And I'm available, remember, every day after school. Well, we only have 2 days, so Thursday and Friday. So, Thursday, Friday. Otherwise, get help on your own.